Hello friends, welcome back to this video on analog communication. In this video I am going to talk about the designing of the sideband shaping filter in vestigial sideband. I have already talked about the waveform of the vestigial sideband. So the vestigial sideband waveform had the upper sideband and the vestige of lower sideband, which is compensating for the left portion of the upper sideband. So this portion is left. Instead of this, I am sending the information with the vestige of the lower sideband. So how it was generated? We took a double sideband suppressed carrier signal. After that we passed through it a sideband shaping filter. So now we will see how we can design that sideband shaping filter. So now the sideband shaping filter has the transfer function. The transfer function of the sideband shaping filter can be written down like So the transfer function can be written down using the unit step function u of f minus fc minus h of f minus fc. So what is u? U is my unit step function. So h of f minus fc represents the transfer function of an odd symmetric. So now odd symmetric means h of minus f is minus of h of f. So this represents the odd symmetricity. So now this h of f follows the odd symmetricity. So if I draw the waveform, so the frequency spectrum, so if this is representing my f, so the low pass filter with the odd symmetry is represented by this. So here this is the positive f. You can see if I go from the value of f greater than 0, if I go to here, so the value is this, and if I go to this side, the value is this. So this is like the low pass filter with the odd symmetricity. So if I draw the low pass filter, so the low pass filter is represented like this. So now what I did, I just made this low pass filter. So this was the low pass filter frequency spectrum. Now I did the odd symmetricity. So if I provide the odd symmetricity to this low pass filter, it would be represented like this. So h of minus f, so h of minus f is this portion. It is minus of hf. So it's the negative mirror image. So it's the negative mirror image of hf. So now if I talk about the second term, it was representing u of f minus fc. So I know u of f is 1. It's a unit step function. How it is represented? Unit step function is represented like this. If it is u of f, it is represented like this. If it is 1 when f is greater than equal to 0, and it is 0 for f is less than 0. So now what here I am doing, I am just shifting the frequency. So I am just shifting the frequency. So u of f minus fc would be 1 now at the shifted frequency for fc greater than equal to 0, and it is 0. Sorry, f is greater than equal to fc and f less than fc. So at fc I have this point. So now this point is shifted to the fc point. So if I draw this was u of f. Now if I draw u of f minus fc, so if this is my fc, so u shift to the fc point. So this is 1. So now this is u of f minus fc, this is f. Now about the amplitude, this amplitude is 1 here, and I am taking this amplitude to be 1 by 2, this to be minus 1 by 2. So now what is happening? I have this function, and now I need to find out minus of h f minus fc. So this was representing h f minus fc, Now if I find out the minus of HF minus FC, so minus of HF minus FC would be, so this is FC. What I did, I shifted, this was H of F, and now I shifted this H of F to the FC. So this portion when shifted to the FC frequency, it represents H of F minus FC. So now I had to take minus. So for minus I took the mirror image. So this represents now minus of F minus FC. So this was H of F. I shifted it to FC. Then I took the mirror image. I got minus of H F minus FC. Now I have to add these two. So now this was U of F minus FC, this is minus H of F minus FC. No, so now I'll add these two. So when I added these two, so till the 1 by 2, here I have just this portion. So this is like this till the 1 by 2. So here I have minus 1 by 2 which is increasing up to 0. So minus 1 by 2 plus something up to I'll get 0. So now here the value is 1. So minus 1 by 2 plus 1 would be 1 by 2. So this graph would start from here 1 by 2 only. After that it will increase up to 1. So now when it is 0, it is 1. So after that I have this filter. So now you can see from here that before FC I have this low pass filter, and after FC this is represented like this. So in my previous video where I was discussing about the vestigial sideband generation, there I use this kind of filter for the generation of vestigial sideband. So now this represents my H of F. So this is H dash of F. So this is representing the filter of the vestigial sideband. So now here you can see how I can generate the vestigial sideband filter using the H of F, which is a low pass odd symmetric filter, as well as the U of F, which is the step function. So with the help of these two field functions, I can generate my vestigial sideband shaping filter. So this represents sideband shaping filter. So here I'll be concluding my session. I hope you understood each and everything. Still, if you have any doubt, you can mail me or you can put the doubt in the comment box. I hope you like this video. If you like it, share it with your friends. Subscribe to the channel and push the like button. Thank you.